Hey folks, Peter Hanson's here. This weekend I was wondering what technical demo could I do to showcase some of my skills and do something simple with an LLM and SQL. Now this is by far not the most technical thing I'll do, but I think it showcases the ease with which you can build something practical without too much effort. So what are we going to build, you might ask? Well, it's Text2SQL. You probably would have guessed that, right? There's a lot of folks who claim to be able to do it, so let's look at how to do it. There's some pitfalls and challenges, so we will step through them very quickly and solve some of them in a rudimentary way, the kind of solution that a spare couple of hours can account for on a weekend. Before we dive in, let me take you through what we are going to cover. First up, we will deploy the duckdb-nsql model with Ollama locally on my M3 Pro MacBook. It's got a bit of grunt, so hopefully we should be good. Number two, then we will ask the model a question without any context to see what the answer will be like. It will be without a database schema for which to reference, so obviously the answer will be interesting to see. Up at number three, we will then spin up a sample database that is a blast from the past, everyone's favorite Northwind database that has been transpiled by Python to Postgres. I'll provide the link in the notes. We will then look at, for number four, we will then look at the information schema of this database to get the context of the tables we are looking at for the Text2SQL query. Up for five, we can load that data into MeliSearch, a Rust-based search database for easy retrieval. And then for six, we can write a Python script to integrate the Ollama run duckdb-nsql model with our search-based RAG to see if we can get an accurate query back. And then we can check it out against our Northwind Postgres database. Okay, so this is going to be cool. Strap yourselves in and let's get started. Hey folks, we're going to build out a Text2SQL solution. To do that, first up we need to install Ollama and download the duckdb-nsql 7 billion parameter LLM. So let's go ahead to Ollama and click on the download button. I've already downloaded it, of course. We'll download the binary and then we'll just go to our terminal. So I can just run Ollama run duckdb-nsql now. And so it's asking me for a message, so I can just quickly ask it a simple question like the total number of sales for the APAC region that I've copied from a prompt before. Great, so that's worked. Okay, so now I can just go bye and exit out of that. Another way that I can run the prompt is via a curl command. So I can just make a quick curl request. This endpoint is where the Ollama service is exposed. So I can go ahead and run this curl command, which is obviously got the model duckdb-nsql. It's got the prompt, and then we're just going to do a stream as false because we'll just take the result when it comes through. So let's run that. Cool. So in this JSON blob, there's this response, which is the select account star from sales where country equals APAC and date part, yada, yada, yada. That's not super nice to read, so we might just prettify it a little bit with JQ and pluck out the response. So let's go ahead and do that. So just running this piece of code now, and of course we get the answer. Now this SQL, as we can see, it looks reasonably good. It looks like it might work. Looks like SQL, but of course we haven't really given it any context. We don't even have a database or anything like that to play with. So this is clearly, probably not going to work against a real database. And this is a really good example of why LLMs are just kind of amazing technology, but equally just kind of predictive text. Yeah, so I'm going to spin up Northwind database locally. So, and yes, this is the blast from the past. We're going to spin up Northwind, but this time let's do it using PostgreSQL. Luckily, I found this repo on GitHub by a chap by the name of Pascal Thomas. He's done an amazing job, so please do give him a star when you go to use this. This has a Docker Compose with both Postgres database, pgadmin, and a Bootstrap script to load in the Northwind database. Let's go ahead and clone it and spin it up. Cool, so just having a quick look at that Docker Compose. So we'll just go back to the terminal. In order to spin this up, we can just obviously clone this repo, so we can run these commands. I'm not going to run them because I've already run them, but basically you can just go ahead and git clone that Northwind pSQL repo, cd into it, and then Docker Compose up to get that service up and running. It might take a little bit of time. Cool. Awesome. So now that it's spin up, let's go to the browser at localhost 5050 to log into the pgadmin portal. So as you might imagine, I've already done that. So I'm already logged in. So what I can do is we can just do a bit of an explore of the tables. There's this orders table that I can take a look at, just to check that it's got some data in it. And of course, we've got order ID, customer ID, and a bunch of customer data. So, like ship name and ship address, etc., and the ship country. Cool. If I scroll down even further, within every database, there's something similar to what's called an information schema. And we're going to take a look at it to see what are the columns and the tables that are in this particular Northwind database. So let's go check it out. Cool. So this gives us the table catalog, table schema, and table name, as well as the column names, ordinal position, and some useful information such as, like the UDT name, which is kind of like the column type, if you will. Cool. So with all of this information and the ordinal position, we can kind of get an understanding of all of the different tables and columns that make up this Northwind database. So this is really useful information to know. Cool. So as you can see, we've got a bunch of information here in regards to the tables in Postgres loaded from the Northwind database. We can use this information to form the basis of our prompt engineering. In other words, to ground our prompt with some context about the types of tables and columns available in the database. Yeah, okay, so let's spin up melisearch, a Rust-based search database that we can use to store the table and column information that we can use as a RAG for the LLM. So jumping across, as you can see, it's got 47,000 stars, so it's wildly popular, this one. So first up, we need to do a Docker pull those commands, do the Docker pull and the Docker run. We've got that sorted out. I'm not going to run it because, of course, I've already got it spun up. And now that this is already ready to rock and roll, let's go ahead and get some data in there. Okay, so first up, we need to load some data in from the PostgreSQL information schema into melisearch. So let's clone my repo Text2SQL-blog and get a Python environment set up and clone the repo with the code in it. Cool, so let's go ahead and do that. So here's the commands, and I've obviously already created this repo, so I'm already good to go. But effectively, you just do that git clone, and then with then cd into it. I'm going to use UV to set up my virtual environment, then source that, and then pip install a couple of useful libraries. Obviously, I've got a typo that I need to correct there. A couple of other typos here, like a clone. So just get that done. I'll fix this up in the notes, and we should be good to go. Okay, so after that, we've got a .m file. Just check that you've got this, but I've got it in the notes as well. So let's just go into the .m file, and it's just got a bunch of environment variables such as our Postgres host, database user, and password, melisearch host. We're not using the melisearch API key in this case. Cool, so you've got all of that in your .m file, and that is all good to go. So let's do that. Okie dokie. So next on to the fun part. First of all, we need to hydrate melisearch. So what we need to do is we need to run this command. You should have in your file list a couple of different Python scripts such as hydrate search, so we can just go check that out. And basically it's connecting to the Postgres database and to the melisearch database. It's getting a couple of it's running this query. It's a bit fancier than what we did with our query, but it's effectively going to that information schema, hitting that columns table or view, and then just doing a bit of an array aggregate, getting all of those results, formatting it again, and then shipping it to melisearch. So let's go ahead and run that. Cool, and it's indexed 14 tables in melisearch. That's really fantastic. Next, what we want to do is we want to run this Python search results. So we'll grab this query, and we want to specify a table, and I'm specifying the orders table. So let's go ahead and do that. Okay, so that spits out the effectively like a create table bit of SQL. So we want to go check out that search result script. We should have done that before we ran that, but again, it's just connecting to melisearch, and then it's just it's got the index defined as Postgres schema, and then effectively it's just getting the first hit, and then sort of shaping it in such a way that it's create table statement. Awesome. Now that we've got the context from our search database RAG, we can use it as part of our prompt to the duckdb-nsql model in Olama to get our text-to-SQL result. Okay, so let's go ahead and do that. What I can do is I'll just run the script like before, and then we can actually just go ahead and have a look at what the script's actually doing. So what I'm doing is just running the script Python Olama e2e.py, e2e meaning end-to-end, and passing in a couple of parameters. First is the table name, and then like the query that I'm going to run. The English language version of the query is the total number of orders from Belgium in 1996. Please remember that this is the Northwind database. It's mostly North America and Europe, and quite a long time ago. So there's no results in 2024 for this this database. So I'll just go ahead and hit this. This might take a couple of seconds because obviously it's kicking off an LLM that's running on my little old M3 Pro MacBook. Cool, so it just comes back. Hopefully it'll come back with a nice bit of SQL. Okay, cool. So what we've got is select count star from orders where ship country equals Belgium and order date between
the start of 96 to the end of 96. So that looks pretty solid. Let's go check whether this actually works with our Postgres database. Okay, let's go to pgadmin. I've got it already here. I'm gonna actually paste it in, sorry, not post. So just scroll down a little bit further and let's kick this query off. Okay, so it returns a result. So that looks like the right result, but let's just triple check. Let's have a look at some orders and just see if that's makes sense. So yes, order date, that all looks pretty good. Charleroi in Belgium, so that's all looking good. Awesome. So that's pretty much the size of it. Hopefully, obviously this is just one use case, and obviously productionizing this and going through the edge case would be some work, but I thought, hey, it's a Sunday, let's have some fun, let's give something cool a go, and hopefully you've enjoyed coming along for the ride. So let me know what you think. Thanks so much.
Okay, thanks so much for sticking with me until this point. Hopefully it's been a fun walkthrough of Text2SQL and a little bit of learning as well to go along the way, and hopefully it also inspires you to sort of go and build something interesting yourself. My name's Peter Henson. I run a consultancy called Cloud Shuttle. If you're ever interested in getting some help doing something like this, feel free to reach out. Would love to help you. Doesn't matter how big or small the problem is. We're always excited to look at new technology and help teams solve this problem. Okay, thanks so much. Cheers. Bye.